Hi, it's Tom from Technocamps here. In this video we're going to take a look at programming our Arduino using C++. So we're going to be writing some Arduino code. So far in these videos we've been using a block-based programming language, so it's very similar to things like Scratch if you've used Scratch before. And we've used that to program our Arduinos. And the benefit of this is that it's fairly quick and fairly simple to get programs working with a block-based programming on Arduino. However, most Arduinos are programmed using the C++ programming language, and we're going to take a look at doing that in this video. Before we can start programming, we need to talk a little bit about variables, if-else statements, and setup and loop methods. So the first thing we're going to look at are variables. So when we're programming in C++, we need to think about what type of thing we want to store in a variable. So hopefully you can remember what a variable is from other programming languages you've used. So you may have used Python, you may have done some Visual Basic, you may have used variables in Scratch, right? And these are essentially a name that we can store something in. So we create a variable that has a certain name, and then we can store different things in that variable. Now, some programming languages like Scratch or Python, they don't really mind what you store in a variable. You can store anything in a variable, and it's as simple as that. But some programming languages, the type of thing that you put in a variable really matters. So C++ is one of those languages. And when you create a variable, you need to tell C++ what type of thing you want to store in that variable. So let's just have a look at an example. Two types of thing that we might want to be able to store. So we have numbers. I think those are fairly self-explanatory, 1, 2, 3, 4. And booleans. So boolean is a true or false variable. So let's just have a look at some examples. Down the bottom we have 4 different variables. So we have a light on variable that we would like to store whether the light is on. We have an age variable that we would use to store the age of someone or something. We have a switch pressed variable, which we'd like to store whether a switch has been pressed or not. And we have a marks variable, which would presumably store how many marks someone got for something. And we can specify what type those variables are. So you can see that light on and switch pressed have a line going to the Boolean type. So they are Boolean variables. We would like to store in the light on variable true or false. The light is on, true, or the light is on, false. That doesn't make any sense for age. Storing your age as true or false doesn't really make any sense, and that doesn't make any sense for marks either. If someone asked you how many marks you got in an exam, true or false is not really an answer to that question. So we would want to use some sort of number type to represent those variables. So age or marks are number variables. There are quite a few other types, but we're only going to be looking at these 2 today. We also need to have a look at the if-else statement. So an if statement is like when someone asks you a question. So if someone said to you, if you are wearing a jumper, then stand up. That would be an example of an if statement. They are asking you a question. If the answer to that question is true, then you do the next instruction. So we have a question here. If you are wearing a jumper, if that is true for you, then you do this. If it's not true for you, you don't stand up. Let's take a look at a different example. If you have blue eyes, then clap your hands. So if you have blue eyes is true, then you would clap your hands. If you have blue eyes is not true, if it's false, then you do not clap your hands. So that is an if statement. It is like asking a question. And if the answer to that question is true, then you do the next thing. If it is not true, then you skip the next instruction. Now, down the bottom, we have an example of an if-else statement. So this is a statement that lets us specify what to do if the answer is true and what to do if the answer is false. So, if I ask you if you have green eyes and the answer is yes, you do, or true, then you would act like a chicken. That's the next instruction. If the answer to you have green eyes is false, because you don't, then we specify what you should do. You should act like a cow. Okay? So this is an if-else statement. We get to say what you should do if the condition, so the condition here is you having green eyes, is true, so that's here, and what to do if the condition is false, which is here, you act like a cow. So that's a really quick introduction to if-else statements. The last thing we need to look at are the loop and setup methods. So every Arduino project, if we're using C++ to write our code, has a setup and a loop method. So they would look something like this. If you started a new project, you would see void setup and these squiggly brackets, and void loop and these squiggly brackets. Okay, and all of your code would go inside these methods. So what are they and what do they do? Well, the setup method is a method that runs once at the beginning when you turn on your Arduino or when you start your program running on the Arduino. So any code you put in this method will be run once at the beginning. So typically what we would put in here are things, lines of code that set up our Arduino the way that we want it to. So we tell our Arduino that certain pins are inputs or certain pins are outputs, things like that. The loop method is a method that runs over and over and over again until the Arduino is turned off. So any code that you put inside the loop method will be run over and over and over again. Okay, so that's usually where you put most of your program. Let's now go to Tinkercad and try to create a simple Arduino project that turns on a light when a button is pressed and turns the light off when the button is released. Okay, so I'm back on the Tinkercad website and I've already created a project for us to work on. I'm just going to load this up. I've already added an Arduino Uno and a breadboard, and I've connected ground, 0 volts, and 5 volts to these two strips down the side. So if you're not sure how to do that, go and look at one of the first two videos. Okay, I want to build a circuit that allows my Arduino to control an LED, but also to be able to know when a button has been pressed. So first off, I'm going to add an LED. I'll leave the color as red, I think. Just going to rotate it and add it to my breadboard up here. Every LED needs a resistor, so I'm going to get a resistor from here, set it to 220 ohms, which is the value we've used for all our resistors. Just rotate that round again, and connect ground to this side of my LED. Okay, so now my LED is connected to 0 volts through this 220 ohm resistor. The other end of my LED I want to connect to my Arduino, so I'm actually going to connect it to pin 3. So I'm just going to click here and create a new wire that goes down here and connects to pin 3. Okay, so when we set pin 3 to be high, that will make 5 volts flow down this wire through our LED, through the resistor, and to ground, which will turn it on. So now we can turn our LED on or off using the Arduino. Remember that these breadboards, these holes are connected together in horizontal lines, whereas these ones are vertical. So the electricity flows through this wire along this line into the LED, out the other side, along this line, and through the resistor, then down this column, all the way to this wire, through the wire, and to ground. Okay, so that lets our Arduino turn a LED on and off. We also want to be able to have our Arduino sense when a button has been pushed. So I'm going to add a button. Again, I'm going to rotate it, and you need to be careful about this because it matters which way round you rotate this. So I'm going to just put that down here, rotate it 90 degrees. So you can see the little blue lines where you can connect wires. These are now sticking out the left side and the right hand side, not sticking out the top and the bottom. Okay, so make sure that you get that right so you have the same as me. I'm now going to just drag this down here onto my breadboard. So the way this works is when this button is pushed, electricity can flow from this side, from the bottom, to the top. Okay, so if I connect this side to 5 volts and I press the button, 5 volts will be able to flow through the switch and out the other side. So I'm going to connect one side of my switch to 0 volts. So I'm going to use a black wire for that. So 0 volts or ground is connected to the bottom of my switch. And I'm going to connect the top of my switch to my Arduino. So I'm going to go and connect it to pin 2, and I'm going to change the color to be yellow. Okay, so I can tell the difference between the wire that connects the Arduino to the LED and the wire that connects the Arduino to the switch. Okay, so that's almost done. The problem is that when I press my switch, then this pin of the Arduino will be connected to 0 volts. But when I let go of the switch, nothing really happens. So this wire will no longer be connected to 0 volts, but it won't be connected to anything else either. So it will just kind of float around at a kind of random value. And that's not what we want. We want it to either be low, which is 0 volts, or high, which would be 5 volts. So we're going to use a resistor for that. So I'll make a new resistor. I'm going to rotate it 90 degrees, and I'm going to change it to be a 10 kilo ohm resistor. Okay, so it should be brown, black, orange, and then gold on the end. And I'm just going to put this over here so that one end connects to this plus line here, so it's connected to 5 volts, and the other line I'm going to connect, just put it, actually let me just move the switch slightly, okay, like this. So I'm going to connect the resistor to the switch as well, okay. Oops. Okay, so now what we have is we have a circuit that When I press this button, we're connecting this wire to 0 volts, and when I let go of this button, it's connected to this resistor to 5 volts, so it's going to pull this wire up to 5 volts. Okay? If you don't fully understand that, that's completely fine, because really we're talking about computer science, and right now this is electronics, so don't worry about that. The result of this is that we will either get 5 volts or we will get 0 volts on this wire or into this pin when we press the button. Okay? Which means that when we read that value, we can easily tell whether the button has been pushed or not. Okay, let's write some code. So I'm going to press the code button. Okay. From here you have to go and select text, so yours probably shows up as blocks first, like this, so you just get rid of that code by clicking and dragging it over to the left, and then go up to the top where it says blocks and click text, and it'll give you a little warning saying, are you sure you want to do this? You have to say continue, you do want to do that, and you'll be given a little Arduino code editor for you to write some code. So here's our setup and here's our loop methods that I talked about before. So any code we put inside here will be run once at the beginning when we turn on our Arduino. Any code we put inside this loop method, so we put here, will be run over and over and over again. So the thing we want to do in the setup that we want to do right at the beginning is we want to tell the Arduino how we are using the pins 2 and 3. So pins 2 and 3 are connected to our circuit. One of them is an output, so that's pin 3, because we're using it to output something to turn the light on or off. The other one is an input, so pin 2 is connected to a switch, which we are reading the value, we are taking input on that pin. So to tell the Arduino that that is what we're doing, we need to use this method called pin mode. Okay. So pin mode is a method that takes 2 arguments. It needs 2 things to do its job. The first is the number of the pin that we are talking about. So let's do pin 2. And then we have a comma. And the next thing is whether it is an input or an output. So pin 2 is an input because it's connected to our switch. So we write in all capitals input. Okay, and these 2 things go inside these rounded brackets and they have a semicolon on the end. Okay, if you forget the semicolon, it will not work. Okay, let's now do pin 3. So pin mode of pin 3 is an output this time. Okay, so pin 3 is connected to our LED and we are using it as an output. So this code in the setup method will run once at the beginning. So when we turn on our Arduino, we will set up which pin is being used for what. And we don't need to do that over and over again. We only need to do it once. So that's why it's in the setup method. Now, inside our loop, we need to write the code that we want to happen over and over again. So there's already this delay in here, and that's because this isn't a real Arduino, it's a simulated one. So we just need a little bit of a delay to make the simulation run a little bit better. I'm actually going to, I'll leave it like that. Okay, so we'll leave it. This delay means that when the Arduino gets to this line here, it will wait 10 milliseconds. So that's 10 thousandths of a second. Okay, so it's not very long at all. If we change that to a bigger number, it would wait more. So if we changed it to delay 1000, then the Arduino would wait for 1000 milliseconds on this line. Okay, and 1000 milliseconds is 1 second. I'm going to leave it at 10 for the moment, so 10 milliseconds. What do we want our Arduino to do? Well, we want our Arduino to turn the light on when the switch is pressed. Okay, so we're going to need an if statement. So we're on to write if, and then we have a condition inside some brackets. Then we use these curly brackets to put the code that runs if it's true. So if true, do this. Okay, this is a comment that starts with these two slashes. Okay, and then if the condition is not true, we're going to use an else statement. I'm going to put the code that we should do if the condition is not true in here. So if not true, do this. So what is the condition that we want to check? We want to check if the button has been pressed. How do I do that? Well, there's a method to do that. It's called digital read. Okay, it's called that because we are reading the value of a digital pin, and a digital pin can only be high or low, which is going to be 0 or 1. 0 is low, high is 1. So the digital read method takes one parameter, one thing to do its job, and that is the pin that we are trying to read. So we're trying to read pin 2. So I put pin 2 in there. And if I just leave it like that, digital read will go and read the value of pin 2, so whether it's a 0 or a 1, whether it is high or whether it is low, and it will return that value. But we're currently not doing anything with the value that it returns. We're not storing it anywhere. So I'm going to store it in an integer. Okay. So this is how we create a variable in C++. We have the type at the beginning, and then the name, then the equal sign, and its value. Okay, so if we just did this, okay, this would create a variable called button, which is an integer. So an integer is a type of number. It is a type of whole number, so we can only have whole numbers. That's 1, 2, 3, 4, or -1, -2, -3, etc. So we cannot have things like 5.2 or 7.1. So this is a variable that can only store whole numbers. And in this case, the button variable holds the value 1. Okay. We don't want it to hold the value 1. We want it to hold the value that we get from reading pin 2. So we use the digital read method. So this line will find out whether the pin 2 is getting a high or a low, and it will store that in the button variable. Okay, now our condition. So we want to check if the button is equal, so we do comparison using these double equal sign, so rather than the single equals. So if our button is equal to 0, then we know the button has been pressed. How do we know that? Well, this side of the button is connected to 0, and when we press the button, we're going to connect this wire through the button to 0 as well. So we'll have 0 on this yellow line, which goes to pin 2. And then we read pin 2 up here using the digital read method and store the value in the button variable. So if the button is pressed, then the button variable will be set to 0. If the button is not pressed, then the resistor that's connected to 5 volts here will pull this line high, and we will get a high voltage on this line and on this pin, and digital read will return 1 to tell us the line is high, to tell us that pin 2 is getting a high input. So what should we do if the button has been pressed? Well, we should turn on the light. How do we do that? We use the digital write method. So digital write, and notice that when I'm writing these out, I'm using a capital letter for the sort of next word. So pin mode, that's two words stuck together, and we use a lowercase on the first word and an uppercase letter on the second. So pin mode, the M has a capital, is capitalized. Digital read, the R is capitalized. Digital write, the W is capitalized. So you have to get these exactly right. Okay, these are the name of methods that already exist. So what does our digital write method need? Well, it needs to know which pin we are writing to. So we want to write to pin 3. That's the pin that we want to control. And it needs to know what it should do, whether it should be high or low. So let's set it to high. So we write high in all capitals. So if the button has been pressed, then set the pin 3 to high, which will turn on our LED. If the button has not been pressed, I'm just going to copy and paste this line, we should set pin 3 to be low. So we write low in all capitals. So if we've got this right, when we start our simulation, if I press the button, the light should turn on. So let's just have a go. Okay, so the button is not pressed and the light is not on, and if I press the button, hey, the light turns on. Okay, so I can press and release, and the LED turns on and off. Awesome. So we can also easily try swapping that behavior around. So how about we have the LED turn on when the button is not pressed and turn off when the button is pressed? Have a little think about how you could do this before I tell you the answer. Okay, so the simplest way to do this is to just change the condition that we are checking in our if-else statement. So here I'm checking if the button is equal to 0. That means I'm checking whether the switch has been pressed, whether the button has been pressed. Well, now I want to check whether the button has not been pressed instead. So if the button has not been pressed, this button variable will contain the value 1. So I can change this 0 for a 1, and now I am checking whether the button has not been pressed. So if the button has not been pressed, button will equal to 1, so this condition will be true, and we will run this code. If the button has been pressed, then this condition will not be true, and we will execute this else statement instead and set the pin to low. So let's try simulating that now. Yeah, so I start the simulation and the light turns on. When I press the button, it should turn off. And it does. Okay? So we've managed to invert the behavior really easily. Okay, that's all for this video. We've only just had a quick look at programming the Arduino using C++. There is a lot more that you can do using Tinkercad. If I just make the code smaller and have a look at some of the other modules, we have all sorts of things you can connect to Arduinos. We have switches, we have potentiometers, motors, servos, we have RGB LEDs. That's an LED that can show red, green, and blue. Okay, so you could do lots of different colors. We have photoresistors, ultrasonic distance sensors, buzzers, all sorts of things. So if you're interested in this, try having a play, try connecting different things to your Arduino. You don't have to use code to program them. It's perfectly okay to use the block programming language. In fact, it's probably easier and quicker.